Welcome back to the Deep Dive, everyone. Today we're looking at something pretty fascinating. I mean, it's not exactly front page news, but it's something that's quietly reshaping our world. And that's how we're going to power all this artificial intelligence.
Yeah, it's really something. We all use AI every day, Every time you search for something online, get a product recommendation, or, use one of those new AI image generators. But all that computing power, well, it takes a ton of electricity.
Yeah, like how much are we talking?
In 2023, the data centers for companies like Amazon, Google, all those big names, Meta, Microsoft, their data centers use something like 90 terawatt hours of electricity.
Wow.
And to put that into perspective...
90 what? Terawatt.
Terawatt hours, yeah. That's about the same amount of electricity as New York City and San Francisco combined.
Oh, wow. So this is not just like, a passing trend. This is a huge deal, right?
Oh, yeah, it's only going to get bigger.
So how are we going to handle this? Like, how are we going to power this AI-driven future? Well, that's what we're diving into today. We're looking at a company called GEvernova, which has a pretty impressive history. I mean, we're talking about a legacy that goes back to Nikola Tesla and Thomas Edison.
Yeah, they definitely have the experience.
And get this, right now, their hydropower turbines at places like Niagara Falls generate something like 567,000 kilowatts, like every second.
Wow.
It's amazing, isn't it? Mm-hmm. So what we want to understand today is how GEvernova is getting ready to meet this, this massive surge in energy demand from AI, and kind of give you a better idea of what this essential infrastructure looks like.
Well, I think one of the most interesting things about GEvernova is their approach. They have what they call this end-to-end solution for energy. So they're not just, generating power. They're doing everything from designing and building the power plants themselves. And we're talking about all kinds: wind, water, gas, you name it. And they're also the ones who transmit that energy over long distances and then manage the whole electric grid. That's a pretty big deal.
Yeah, that's a lot. Like, can many companies do that?
Very few, actually. Not on that scale.
So what does that mean for us? I mean, for the average person?
Well, it means that, the energy ecosystem that powers the technology we use every day is more streamlined and potentially a lot more reliable.
Okay, that makes sense. So let's talk about renewable energy. I mean, that seems to be a big part of the solution, right?
Absolutely.
And GEvernova is doing some pretty cool things with their Haliade-X wind turbines. Like, those things are massive.
Oh, yeah, they're huge.
Like 260 meters tall. That's like taller than most skyscrapers. And the blades on those turbines are as long as apartment buildings. Each one can power about 1,000 homes.
That's right. And they're not just, building them. They're actually involved in some really big projects. They've got a 3.6 gigawatt offshore wind farm in the UK, for example, and another large project with Ørsted off the coast of New Jersey. And these are long-term commitments, which I think is really important. We're talking about service contracts that last 15 to 30 years.
That's a long time.
Yeah. So they're really ensuring a stable supply of clean energy for the future. I mean, that's a huge investment. And it shows how committed they are to, moving towards sustainable power.
That's great. But, we're not quite there yet. Like, we're still transitioning towards a fully renewable future. And we need something to help us bridge that gap, right?
Yeah.
So that's where their high-efficiency gas turbines come in.
Exactly.
These are the HA-class turbines, and they're incredibly efficient. I mean, they can convert something like 64% of natural gas into electricity. That's amazing.
It really is. And get this, over 40% of the world's gas turbines are powered by GE technology.
Wow. Amazing.
So, reliability is key here. These turbines are running almost all the time, like 99.2% uptime, thanks to, all the digital monitoring and diagnostics.
So they're always on.
Pretty much. And that's super important for us, for the digital world we live in. We need that constant, dependable power source. And the way they integrate seamlessly into the existing power grids also ensures that the electricity keeps flowing without interruption.
Okay, that makes sense. So now think about how we're going to move all this power around. Like from an offshore wind farm or a solar installation that's far away to those energy-hungry data centers that power all the AI. That's where the HVDC comes in, right?
You got it. High voltage direct current transmission systems.
Yeah.
That's a real game changer. With HVDC, we can transmit electricity over incredibly long distances, like 3,000 kilometers or even more, with minimal loss. That means we can use those remote renewable energy sources to power big cities.
Yeah,
And those data centers that are so crucial for AI.
that's really cool. So what else does it do?
Well, it can also regulate frequency, which is really important. And it reduces power loss significantly compared to the traditional AC systems. And it just makes the whole grid more efficient.
So it's kind of like a win-win for everyone.
Yeah, it's essential for keeping up with the ever-growing demands of AI and, well, the whole digital infrastructure that we rely on every day.
So it seems like Vernova, with all this history and all these energy solutions it's offering, it's really playing a key role in building the infrastructure we need for this whole AI age.
Absolutely. They're not just building individual power plants here and there. They're building the whole energy network that powers the AI technologies we all use.
And, that kind of brings us to a final thought for you, our listeners. As AI keeps developing and growing, what other industries that we know and rely on might have to change in a similar way? Like, what kind of fundamental transformations might they need to go through to meet these new demands? And, well, what role might you play in that changing landscape? That's something to think about. Thanks for joining us on The Deep Dive.
Thanks for having me.
It was great having you. We'll see you next time.